Hi everyone, my name is Bhavishya, and in this lecture, let's pack the RIP packet what we have left it to. So, what is the total size of the RIP packet? So, the total size of the RIP packet is, if you look at the header, the size is 4 bits, and if we look at the rest part for each network, that is 20 bytes. Right? Now, what is the useful part out of it? So, let us talk about the rest of the 20 parts. That is, the very first is network, right? Cost about 4 bits. Then the matrix that is also 4 bits, and we have the AFI that cost about 4 bits. So all total 10 bits are useful there in that section, right? Now when we talk in IP packet, there is a concept called word. So one word is equivalent to 4 bytes. Okay, so now how many bits for each network? So the total cost is 20 bytes. That is equal to 5 words. What we did was 20 divided by 4, that gives us 5, that is 5 words. And for the RIP header, it cost about 4 bytes, so the value in word will be 1 word. Right. Now, if there is one network advertised, so the total size in word for RIP packet will be what? So it will be the 6 words all total, because one word is for RIP header. Initially it was 4 bytes equivalent to one word, and rest is 20 bytes, which will become 5 words, because 20 divided by 4, so all total 6 words, right? Now the next thing is the maximum number of network we can advertise in a single RIP packet is, the value is 25, right? Now if I ask you the maximum size of the RIP packet that we can advertise, and the size of it in bytes, what it would be. So for it, what we will do is 25 is the maximum number of network we can advertise in a single packet. We will multiply it with the value that we use in the single network in bytes. So 25 into 20, that gives us 500, and then plus 4, that is our header value, RIP header. So all total, the maximum size of the RIP packet is 504, right? But as we know, that RIP further encapsulates into UTP. So there is also UTP header that is going to be adding with this value of our what 512, right? So we will add the 8 bytes of the UTP header. So the maximum size for the UTP segment carrying RIP packet, the total PDU will be 504, right? So this is the maximum size of the RIP packet. Oh, my bad. 504. And for UTP header 8. So all total it gives us the value 512. So this is the maximum size of the UTP segment carrying RIP packet. Now what is the minimum size? And in words, what will be the value? So for minimum, the value will be what is the minimum size that we can advertise? That is only one network. And for that, what is the value that comes up for one network? That is 20 bits, right? Plus 4, that is our RIP header. And now the UTP header cost about 8 bits. So all total, if we plus everything, that is 32 bytes, right? And if we convert it in words, so the minimum size is 32 bytes. And in words, 32 divided by 4, that is 8 words, right? Now, as we know, there is source IP and destination IP, and also we know that there is destination MAC and source MAC. So similarly, in layer 4, we have source port and destination port, and the value for RIP in that we use is 520, right? So let us revise what we have learned, that RIP gets encapsulated into UDP, UDP further encapsulates into IP, IP further encapsulates into Ethernet frame. Now if I reverse it and ask you, so Ethernet decapsulates us to give what? IP. IP decapsulates to give us what? UDP. UDP further decapsulates and gives us what? RIP. Right. So initially we had RIP packets, right? Header part and the rest 20 bits. Further it's encapsulated into UDP. That is, if we look at the source port and destination port, so the value for RIP is 520. Right? Yes. Now, further it encapsulates into IP, and the IP header, the value for UDP, the protocol field, the value is 17. Right? As we have learned in the previous one that for TCP the value is 6, for ICMP the value is 1. So similarly this. And further IP gets encapsulated into Ethernet. So let us see that what will happen in the Ethernet. What is the value of our source IP, destination IP? What is the value of source MAC, destination MAC with this example? For this, let me pull out the topology. Okay. So as you can see, this is the topology that we are using to demonstrate the example. So example is, this is what we are advertising, the network 192.168.10.0. So here what will happen is when I'm advertising this network, so the rep packet will go out from this port, fast Ethernet 0/0. Right. Now, what is the size of the rep packet? All total. So as I'm just only advertising one network, right? So the value will be 20 bits, the rest one, and 4 bytes for our IP header. So all total that is 24. Right. So this 24 bytes will be encapsulated into UDP. The source port and destination port for this will be 520 value, right? Further, it get encapsulates into IP. So the protocol that we're using to identify what we were using, that is our UDP. So the value is 17. Now, what is the source IP in this example when I'm advertising this network? So the source IP will be 192.168.10.254. This is the source IP, right? This 192.168.10.254. This is the IP address, source IP address that I'm using. And for the destination IP address, we are broadcasting this, right? So the value that I'll be using that is 255.255.255.255. Now further it get encapsulates into Ethernet. So in Ethernet, okay, so the one, the source MAC we will be using, let's suppose the source MAC for this fast Ethernet is A. We are just assuming it. The destination MAC will be broadcast. So all Fs that we will be using. Let's just name it as all Fs right for now. Now I was using this network only, so it was getting advertised by this fast Ethernet from this fast Ethernet only, right? Now let's suppose I'm advertising both of the networks. That is 192.168.10.0 and also network 192.168.20.0. So let us understand for this fast Ethernet 0/0. Right. So initially when I'm advertising from this side, what is the size of the packet? Initially it was 24 because I was advertising just one network. But as we are using two networks, so the size will be 20 for one network plus 20 for second network, that is 20.0 and header part that cost about 4 bytes. And what is the value of source port and destination port? 520 for RIP in UDP. And what is the value of protocol? UDP as the value is 70. What is the source IP? We are talking about this fast Ethernet 0/0. So the source IP is still the same 192.168.10.254. 192.168.10.254. What is the destination IP? It is the same 255.255.255.255, right? We copy this. Now what is the source MAC? As we are talking about this side of this fast Ethernet, the source MAC that we suppose was A. What is the destination MAC? All Fs, right? As we are broadcasting it. Now when we talk about this side, right, network 192.168.20.0, fast Ethernet 1/0, what is the size of the packet? Still, as it is advertising one network 10.0, after that it is advertising 20.network with header. So all total 44, right? Here also. What is the destination port and source port? Still 520 that we use for RIP and UDP. What is the protocol field in IP header? 17 for UDP. What is the source IP? Here the source IP changes to 192.168.20.1, right? As we are talking about the other side for fast Ethernet 1/0, 192.168.20.1. What is the destination IP? Still the same as we are broadcasting it. Great. So what is this source MAC? As for this side we assume it to be A, let's suppose it for this side to be B. So the source MAC is B. What is the destination MAC? All Fs, right? So this was it. So this was the last lecture for RIP. I hope you enjoyed. See you in the next one.